So that was one. The other project, I was going to show you, like kind of what I did and say, oh, isn't this cool, look at it working. And instead, I'm going to show it to you and say, oh, I really need your help. So, I tried to doing something a little different. One of the clients I call on in the federal government is the Environmental Protection Agency here in Raleigh. And actually do some work with them on cloud and this thing they have called AirNow, which is really cool. If you haven't looked at it, AirNow, do a Google search and it will show up. And it's an EPA program where they kind of tell you what is the air quality where you are at this time. So some people, that's a big deal. I may or may not go jogging today if I have some reactive airway disease based on air quality. But they've started to deal with this thing they call citizen science. It's these darn citizens who think they're scientists. And sometimes they say it that way. Because we're not. A lot of us, most of us, don't really know what we're doing, but we can build these things. So that's kind of cool, but it's also kind of scary. So I thought, well, hey, let me start one of these things. I'll probably be 6 months from now still giving you updates on it, but I thought, what if I built an air quality monitor using the tools of this maker kind of community?
What are you going to measure?
Air quality, and that's when you start getting into. See, when you're looking at air quality index, like the one at AirNow that EPA reports, it's specific pollutants, and what they do is they measure the parts per million of those pollutants, and they'll give you an index, and not an overall index, but for that specific thing. You might be sensitive to, for example, ozone. It might bother you for one reason or another. For me, I might be nitrous oxide or carbon monoxide or particulate matter, this ppm 2.5, this kind of stuff. So what they do is they have specific measurements for specific gases. So what I thought is, what if I built up a sensor that could sense all sorts of different gases, your choice, and you could report those results, and then couple it with something like this, because they have a new feature on UBDOTS called GPS Track. So this is a point, but what I could do is I could actually pick up the sensor, and I could go walk on a route, for example, that takes me across Route 40 or some other places, and then record those data points as I go and come back and show, hey, over the course of my route, when I went over Route 40, the air kind of smells bad. Well, that's because volatile organic compounds, nitrous dioxide, other things are there.
And the Raspberry Pi already has a board called the AirPi.
Right. So AirPi exists, and then there's another one called the Air Quality Egg. And when I looked at those, I didn't think that it was good enough. And that's not like I knew what I was doing, but they were generally using last generation sensors, and they and I think the piece that they haven't figured out yet, that I haven't figured out yet, and one thing I asked for help on, is the method that you use to calibrate and deploy that sensor. So I'll give you an example. The air quality, the AirPi, and the other one, Air Quality Egg, use a sensor that's based on a company called SGX. And the thing is that the people didn't want to use the surface mount stuff, so they used the through-hole parts, which is like 2 generations ago. And so what they're selling, SGX is selling now, is this part. And I think I'll show you now. So I thought, well, okay, let me see if I can build something using this current generation part, which has increased accuracy, lower power.
Turn this guy on. Is there a button at the top?
No.
On the back.
What about the base?
The base. That one.
Yeah.
There we go. And so I went to the SGX website, which is kind of the one that people tend to be using. And they have a new sensor. Gosh, is that as bad as it?
Pretty bad.
How bad is that?
That's terrible.
Is it not
Black.
You can move the battery.
focus or light? What is it?
The problem is the battery is
Yeah, cover up the batteries. Like, just put your hand over it.
Yeah.
I'm not going to play with it this morning anyway. Talk about
There you go. That helps.
Zoom maybe? Zoom in.
Get rid of the light.
Right.
That's better.
There you go. So you can see the sensor in the upper right. That is an MICS 4514. It can sense carbon monoxide and nitrous dioxide. And it uses a technology that kind of heats a metal oxide foil, and that reacts with either reductive or oxidative chemicals in the air. And so this one can do both. So it has a reductive sensor and an oxidative sensor on the same chip, and it puts out an analog signal. The thing is that you could surface mount it right to the board, but then you'd be stuck with those two gases, and maybe those aren't your pet gases. Maybe you're sensitive to other things, or you want to measure other things. So I got this thing and put it in a socket, which is I'm not very happy with, but it's a $12 socket, but it allows you to pop out those little things and pop in others, like there's other sensor modules that will measure different things. So that was pretty cool. The thing is that I didn't want it to be an analog thing. For some reason, I thought digital would be better. And I also thought that it would be cool if I could turn it all on and off in a way that might both conserve battery, but also these parts have a specific life. Like because it's heating these elements and there's some reaction that takes place, you don't want to leave them on for forever. So what I thought I'd do is build a little thing with its own power supply. So you can see a buck boost power supply here with the LiPo battery, because I wanted to kind of isolate the power drain of this from the Arduino, especially since I use a fan to pull air through the device. Because if you don't have a fan moving some air through, then you're just measuring the air quality inside your box, not necessarily in the air around it. And then what I did is I kind of started using some new stuff. Which one is a really cool part. If you've ever wanted to build an I2C sensor, there's a really cool thing called the PCA 9306 that all it does is level shift I2C. And it's super simple, really easy to implement, and now it doesn't matter if you're using a 3.3 volt or a 5 volt device, you just connect it and it will take care of that level shifting for you for the I2C bus, which I thought was kind of nifty. Honeywell makes a really slick temperature humidity sensor. I'm not done playing around with this yet, so I haven't removed the final little piece of protective material, but it actually has a special coating on it that protects it from water and dust, which is kind of cool. But it's $12, so it's not cheap, but it's very accurate. And then I use an analog to digital converter, so a 4-channel A to D converter that would take the output of the sensor, but then I thought, well, heck, just put another analog thing on there, which has been really good and helpful in debugging, because I can actually use the ADD sensor to measure voltages around the board, but also measure the battery voltage. And it turned out that I made some mistakes on this that maybe people have. There's one thing I still haven't figured out, so I thought I'd show you where I am right now and ask if anybody has any good advice. The first is, anybody has any connections here at the university or thing where place where I could actually put it in an environment with a known concentration of carbon monoxide or nitrous dioxide to see if this thing's giving me anything other than, a random voltage? That would be really great. I am going to go back to my friends at the EPA, and I think they'll help me, but if I came to them with something that was a little bit more than half-baked, that might be good too. So that was one request for help. Yes.
Is there a Fluke handheld?
There probably is. It's probably, I can't afford it, just like every other piece of Fluke handled stuff. But yeah.
One of the members is not here tonight, is a chemist who is doing stuff for the EE guys.
Yeah.
But he's a chemist and
Make an introduction.
might know
There you go.
Who to talk to?
somebody who knows somebody.
I'm thinking it might be as simple as if I had a 2-liter bottle of Coke and I put a known quantity of 2 reagents, sealed the bottle, mixed the 2, and it would create some amount of carbon monoxide gas. I don't know, but someone's probably figured this out, and it would be very helpful to know that there's some validity to the numbers that come out of it, even though the sensor has calibration curves and stuff like that. The other thing is, I was able to get I'm learning this whole MOSFET thing, and everybody's like new in the world of MOSFETs. Yeah, it's really cool. So I used a P MOSFET and was able to make that successfully work to turn on and off the fan using just a simple signal from the Arduino or the Linkit One. But I failed in implementing another thing, which I was wondering if anybody, I'll show it, and then if anybody has insights and they wish to share at the end of the.
P's are the hard ones. N's are easy.
Really?
Yes.
Yeah, gosh. I had no problem with the P. It was, this is the circuit is that not showing?
No.
Oh, hold on. This was the circuit for turning on and off the motor. So that was really actually pretty simple. The only thing I added was, you see the gate thing doesn't have any. I put a resistor on that gate that would pull it down so that it wouldn't float and do random things. But that's the circuit I used to turn on and off the motor, which is kind of cool because I was able to, with the P MOSFET, you can basically give the device, which is connected to ground, power or not. It's kind of, my mind said this is what a switch looks like, right? The motor is connected to ground, and on the positive terminal, it's either going to have voltage or it's not. If it's not, it's not going to run. If it does, it will. So I thought that one, conceptually, I got. The one that, if, and I don't know, maybe afterwards if somebody can come up and give me some advice on it, but the one that I struggled with was this one in the data sheet for the sensor. This is the gas sensor data sheet. One of the things they described is that you can build a preheat circuit that will allow you to bring the thing up to temperature more quickly, and then you read using the you turn off the preheat circuit. So basically what they do is they say, the heat of this thing is kind of set by the resistance. So you 5 volts in and 82 volts between this and ground gives enough current, E equals IR, that heats this thing to the right temperature for it to take its reading. For this one, they want to heat it up more quickly. They use a MOSFET to ground this here, and then when they're ready to, when the warm-up period is over and they're ready to take a reading, they disconnect this so that now it has to go through both resistors to get to ground. I couldn't make that work. So
Just inverted.
oh sure. So
Turn on, turn off.
yeah,
Vice versa.
I struggled. Anyway, if anybody has a few minutes afterwards and could give me a 5-minute lesson on what I did wrong, I have the Eagle file. It doesn't work, and I'm not quite sure what I did wrong.
He'll tell you everything you need to know. You have to take this.
Okay, absolutely. So anyway, I think that was the long and short of it. I mean, I'm going to continue to work on this. I did some last-minute soldering because the post office delivered something to me this afternoon, and I made the mistake of doing last-minute soldering. So I'm not going to plug it in right now, but I'll pass it around. You guys can take a look. And the idea of this is I am documenting this project. This is, Shane, one of the things you've asked me to do is document my projects. It's a pain to document projects, it turns out, but I'm doing that on the tryembed.org blog. You guys may have heard of. Yes, and so what you'll see is that I have documented the overall project, what it is I'm trying to accomplish, the goals, and then I go into the design of the sensor itself. All this is open source, so all the Eagle files for the boards, all the software as well. You can see a little bit on the physical design. I did a cost analysis piece of work where I said, well, what if I was making 1, 100, and 1,000 of these? How much would it cost? Just, I had some time on my hand. So anyway, that some people you know, that's kind of interesting. And then I'm putting up the software as I develop it. I've been doing this, the guys at Seed Studio gave me a free Linkit 1, so I've been using the program examples are all based in the Linkit 1. But it'll all work on, it works on Arduino, it's Arduino code. And then the integration on the UBIDots is here, and as I get that new GPS tracking feature, I'm going to put that on there as well, you can see how it works. The nice thing about this is the UBIDots guys took this work and created a new tutorial on their site for the Linkit 1. So if you happen to have one of those Seed Studio Linkit 1s, which are actually really cool devices, now there's a whole tutorial on how to get that up and running and start doing basic data logging on your site.
Okay, where did you use the level shift?
Yeah, so I put a level shifter here because who knows, right? I thought, well, hey, if I'm building this thing and putting it up as open source and letting people take the board designs and even publishing the AshPark, sharing the AshPark thing, they might have a 5-volt device or they might have a 3.3 volt device. So the idea was to put this between the device and the sensors so it doesn't matter. So what happens when you connect to this thing, you have to give it, there's basically 4 wires come off the device, the voltage and ground, and then the two I2C, SCL and SCA. What this thing does is it uses that voltage to establish this side, you know, using the pull-up resistors on SDA and SCL, and then the board voltage is connected on this side. So whatever those two are, it just works out the difference. And it doesn't matter; they could be the same, it could be different.
So all the ones out here have to be the same, and the
Yes.
ones on this side have to be the same.
Right, and then this thing will level shift between the two, and it's cheap part and easy to put in.
I was going to say, I've done a lot of 5-volt and 3-volt I2C on the same bus. You know, you just pull it up to
Yes.
3 volts.
Right.
And
Yeah.
I've never run into any problems.
Yeah, and one of the reasons I did is the Linkit 1 specifically said my digital I/O is all 3.3 volt. Don't give me 5; it'll hurt me. So that was one of the reasons, the motivation for that. And now that I've done it, I'm like, why not? You know, it's relatively cheap. It only has, you know, this part, 2 resistors on this side, and a couple pull-up resistors on this side, and that's it. So it's a pretty painless thing to add.
I'm asking because I'm working on a project. I'm using an MCP 23008 port expander.
Okay.
And I'm going to power it. I only have 2 connections, excluding ground, to my Pi, which would be SDA and SCL.
Right.
So I'm receiving no power, nothing's going from the chip back to the Pi.
Right.
So I don't care about the voltage, right? This is a kind of a question.
No,
If I'm going
it's-
to run my chip with 5 volts because I want to run something with 5 volts, and I'm using the Pi only to process my code, and it's only sending a control signal, not a
But
Well,
operation signal.
Let me show you one thing, what little I know, and there's people in here that will add to this, I'm sure. The way this I2DC thing works is there's these 2 lines, and they're both pulled up, right? So this, in your thing, from your board, your MCP, whatever, that's pulled up to 5 volts. Same thing here. And then the way the signals are sent on an I2C bus is the device pulls that low and then lets it go back up to let it to send the signal. So the issue might be that you have a 5 volt signal coming on SDA and SCL, and if your Pi is sensitive to that,
Which it is.
then that could be an issue. Now that you can fix that with, you can put a resistor and basically do a voltage divider, but I don't know, I mean, to me, this seemed like a pretty slick solution. But
Well, that's kind of where the question I was going to ask. Well, even though I'm not taking there's no signal other than those two going back to the
But they
pi.
always talk back and forth.
But that's a big other than.
Yeah,
Well, yeah, actually,
they always,
just because you think you're only sending something there, especially on R2C, it's gonna be going both ways.
Exactly,
regardless
it
of what
has
you're
to.
thinking. Because a lot of times it said, hey, I want address, 68. Well, it's gonna respond back and say, okay, I'm 68, I'm on the bus, send away.
Okay.
It's going both ways. Unlike, like with the LED strip stuff that I do, it's, SPI, and technically they're 5-volt chips, but I usually use a level shifter, but I can send the 3-volt signal over there. But it's just, all it's doing is flipping that pin.
So then, should I?
you should probably,
I
yes.
have 4 really nice levels.
I squared
haven't used
C,
yet.
I squared C is
Should I
bidirectional.
connect those to the SDA
Well,
and the
the only thing
SCL?
with the level shifters, like I had a level shifter too from, I don't know, SparkFun or something, is that the bidirectional nature of it. You have to shift one way and then you also have to shift back. And
Yeah, they have to be.
this is cheaper, this chip is cheaper than, buying one of the, those however many of those level shifters you need, I think. I mean, it's just like $1, maybe $1.20, $1.30. Did you keep?
I mean, if you want
And
something
it
regular,
does all
basement,
of
like,
the pins that need to be shifted.
4 channels.
It does all the pins that need to be, it's specifically for I2C, but it will also do all the higher bit rates of I2. I don't know, but the other thing you may not know about I2C is you can run at different speeds, and depending, that's when you get into the, how big is your pull-up resistor, and what's the capacitance of the wire that you have, how long is the wire, and all those kind of craziness. And this thing can operate at those higher speeds.
What's the number of that?
That's a PCA 9306.
Is that a surface mount?
It is.
PCA 9306?
But they PCA 93, and now here's another mistake I made, because I make a bazillion mistakes. It is surround, and it comes in 2 sizes, and I ordered the chips in one size, and I put the footprint on the board in the other. So the last minute shipment I told you I got from the post office today was the good news, they do make it in a SOIC, SOIC 8, which is a more human-sized chip. But the other one is the VSOP 8, which is so when you're looking at that, if you look at the one that's right next to the one that's farthest left on the board, when you see the connector, the farthest left on most surface mount chip, that is the PCA 9306.
If you have well-behaved devices that follow the I2C spec,
Okay.
it should be impossible for they're open drains, so they're only ever pulled to ground or floating. Like
Yes.
So there should, in theory, never be, the source voltage shouldn't be coming through on those lines, so it should be safe.
So if I'm using a microchip, good quality, MCP 8-port, I'm gonna power it with 5 volts.
Right?
It's gonna
And
power
your high
a
is
couple of
3.3.
LEDs.
Yeah.
This is just to show something. And never the 3.3 and 5 have a problem.
No, it's
I'm
got
never gonna
it's
send
got
5 volts to my Pi.
it's got 2 wires going from the port expander to the Pi.
Right.
Yes,
Right.
SDA and SCL.
Right. And somebody is pulling those up to some voltage.
Right.
It's either done on the Pi end to 3.3, or it's done on the port expander to 5,
One
or
of the other
both,
two.
which would probably be bad,
Right.
right?
Yeah.
And so if it's the Pi that's pulling up to 3.3, that may not be high enough for this guy to recognize it when it pulls it low to say that it
Yeah.
changed state.
Technically, the chip that he's working on, that he's using, should not work on 3.3.
Works like a charm.
The problem is that it does, as long as your distance between the chip and the Pi is not that far. If you start stretching it out, all the added noise and whatnot on the wire is gonna cause problems.
Yeah, I'm only.
Bottom line, good design principles, put a level shifter between 5-volt and 3.3-volt devices.
Okay, so where does the level shifter go? I'm at between SD
Can
and...
I erase? Everybody's okay with this chicken's cut, right?
So the only lines I've got going to the Pi are SDA and SCL.
Yeah.
Yeah,
So-
just
so
go
we'll-
between the Pi and the bus.
On the,
So
on the
here's-
SCA and the SCL lines.
Yes.
Okay.
Here's your Pi, right?
Yep.
And here's your MCP device. So there's a SDA line, and there's an SCL line going between the two. That's what you're telling me, right?
Correct.
On these lines, their I2C needs to be pulled high. So first question, which side do you want to pull high? Well, let's put in the level shifter.
It isn't convenient to disable the pull-ups on the Pi side, so the quick answer is that it's being pulled up by the
Yeah, the
Pi.
Pi.
So then they'll be pulled high to 3.3, and then the question Paul raised is one, will the MCP recognize those as being pulled high when they're only at 3.3 volts? So one way
I mean,
around.
I'm already using it at 3.3, so I already know that it works at 3.3.
So, and it may, because right, Carl's saying, you know, they might be close enough. But the other way to do it would be put the level shifter in between, right? That's that PCA 9306. And now you'll have a resistor that'll pull it high to 3.3 volts here, right? 3.3.
It's actually inside the Pi board, but anyway, yeah.
Okay, but
It's existing.
But to your point, yeah, so SDA and SCL are pulled high on this side to 3.3 volts, and they're pulled high on this side to 5 volts for the MCP. And so both sides see an I2C bus in the voltage that they're used to seeing. And the level shifter takes care of moving the data between the two, and it isolates those, so none of this voltage goes over there, none of that voltage goes over there.
The data sheet for the MCP will also tell you, here's the minimum
Right.
logic.
That's the
one.
key.
Exactly.
I've never seen that logic one like lower than 3 point, you know, for like every time I've checked it out, it's always, I'm not saying.
2.7 or something, yeah, you're right. You probably work as long as they're close together and there's not a lot of noise, but this might be a more
Does
robust.
the level
robust
shifter
solution.
chip also have a VCC in the ground?
It does, yeah.
Does
So
it matter
you're
which you
gonna.
look at too?
Well, yeah, you usually have low voltage, high voltage in the ground.
Right.
That's correct, exactly. So this thing actually, you make 4 connections. There's an HV side. There's a, I'm sorry, LV section, an HV section, and then their common ground. Yeah, and that's why it's an 8-pin chip. The cool thing about it is, if the post office hasn't gotten your new chip there quick enough, the SCA and SCLs are directly across each other, so you can just lay a wire across the two, and you can continue to work on it while you're waiting for the new chip to run.
Well, what I'm trying to do with it, we're doing one thing where we're going to use a transistor
Yeah,
to switch a 12 volt source to make a buzzer go off
cool.
with the Pi, okay?
Yeah.
Then I'm going to have some MOSFETs. We're going to do some string of LEDs, and then I want to say, now suppose we had something that isn't going to draw a lot of current, but I don't need a MOSFET. We're going to use the port expander because we want to be able to make sure nothing
Yep.
goes, this 5 volts doesn't go to the Raspberry Pi, but will control our things. I just want to give them a bunch of different ways to hook things up.
This would be a good way to do it, and the nice thing about this too is, you know, with I2C, what, 64 devices? Something like that, right? As long as you don't have 2 things with the same address. But you think of it as an expander, you can have all sorts of stuff hanging out over here, all with its own 5-volt power supplies and all that kind of stuff, and you're not taxing your power drain on your Pi. I mean, yeah, so you could do that. Anything else?
One quick thing. Do you see the upper portion of the web page up there where it says info, email list info, personal and project pages, and so on? If you visit this site with a smartphone, it doesn't have any of that.
Correct.
It has a little thing with 3 parallel lines over here.
It's a hamburger.
It's a little hamburger. Never heard of
You gotta
whatever
click
he
on
said.
hamburger.
And when you touch that hamburger, then you get the menu that corresponds to this. But if you're not smartphone savvy, you might visit this site and say like, what the heck, right? But if you've been using your smartphone for about 72 hours, you'll get past that.
You can usually, if you're on Android, there's an option to say request desktop site. There's a route
Yeah.
it'll
Right, which has its own set of
Well, they
issues.
don't. A lot of the sites like that, like, I just redid the Monaco website. It won't do that because it figures out the layout purely based on your screen size, which is mildly annoying, but it doesn't work.
So, last thing, if MOSFET help, anybody can come grab me afterwards. Anybody access the lab and Pete could make an introduction, and that would be awesome. And
I'll send, I think it's Alan